So we're going to continue looking at differential equations, but the questions we've looked at so far have had very few words in them. These are just what I call the wordy differential equation questions. And for people like you who haven't done mechanics and may not be doing physics particularly, these can look quite scary. Okay, and I haven't done mechanics and I'm not a physics specialist either, so I sort of know where you come from. So let's read it through and try and pick out some key things as we go through. We've got a colony of bacteria increases at a rate proportional to its size. So we've got it increases proportional to its size. These are important bits. In 20 hours, the size of the colony increases. So that whole sentence that's important, from 1500 to 3000. Formulate a differential equation. Solve the differential equation for n, the number of bacteria at time t, where t is the number of hours after the size was 1500. Then we've got some other stuff to do. So what we have got here is we have to first of all create, if you like, a differential equation. And that differential equation will be based on the letter n and the letter t, where n is the number of bacteria. And if I was doing an exam, I think I'd just write this down to help me focus on exactly what I'm doing. And t is going to be time. And actually it's time after the size was what it is to start with. Right, think back to GCSE, and if something is proportional to something, if it said in a question, y is proportional to x at GCSE, how did you show that? What notation did you use? What symbols did you use? What did you do? Yeah, you're writing it in the air. You say y is proportional to x. That's the notation for it. And can you remember what you did next? You've got to put something else in there as well.
We found out what k is.
Yeah, so you change that sign there to equals k times by. So you get y is proportional, or y is proportional to x becomes y equals k times by x. So what you do here is you replace the proportional sign, gets changed to equals k times by something. So this question here said the colony of bacteria increases. Well, that's talking about the size, and it's talking about how it increases. So it's talking first of all about how the size increases. Well, the size is n. How it increases. What notation will be used for how it increases? How it increases it's a rate of change. And a rate of change is always d something over d something. Okay? The rate of change is how the size changes over time. So that dn you can think of almost as the change in n, the change in size, over dt. You can almost think of that as the change in time. So where you see increases at a rate, you should be thinking one of these differential things like this. So the question said the size was increasing. That is dn dt. So the size increases corresponds to that. And it said at the top, if I can get it all on together, it increases at a rate proportional to its size. What letter are we using for size of bacteria? The number of bacteria? N. So we get this. So that first sentence, a colony of bacteria increases at a rate proportional to its size, gives us this. So that basically is the first sentence of that question. Is it sentence? Sentence. A or an E in here?
Sentence.
With an E. Okay, there we go. That does look better. So if I've got this from the first sentence, I now replace that proportional sign with equals k times by n. So that proportional sign there has been replaced with what's in that red box there. And now here I've got a differential equation. So what do I do to a differential equation? What's my first step? Separate the variables. Okay, so my variables are n's and t's. So I'll keep the dn over there, where it is on the left of the equal sign, and this n here I will bring down here. So the n's are together. I can leave the k where it is, but I don't want the t with the n, so I'll move the dt over here. So that's my separated variables. And once I've separated my variables, then I integrate. Okay. So that's what I get next. I've separated my variables and I've integrated. So I've got here that I'm integrating 1 over n with respect to n. What do you get if you integrate 1 over n? Log of n. What do you get if you integrate k with respect to t? And I've finished integrating, so I put my plus c on there. So this is my, what's this? This is my general solution. Yeah. Now, we need to go back to the question again, because we need to find out, well, we've got two letters here we've got to find out in a minute. In a minute we will need to find the things that aren't our variable. So we will need to find k, and we will also need to find c. That's an issue that we've got to do in a minute. Oops. Now, what information is given to us in the question? What was the size of the colony at the start of time in this question? 1500. So at the start, what was 1500? What letter was 1500? N was 1500. And this was at the start. So at the start, what will t be at the start? 0. Yes. Okay. So we get that from, it increased from 1500, well that must have been at the start. So now we substitute those values in. So I get log of n equals k times by t plus c. So what have I now established?
C equals log of 1500.
Yeah, that's right, because that's going to disappear. So I now know that c is log of 1500. Okay, I now know c. So I'm happy about that. So now I go back to my general solution up here, and I can rewrite it, and I needn't have a c in it anymore. It's now log of n equals kt plus log of 1500. Okay, so that is my slightly improved general solution. It's still a general solution because there's still a k in there that I don't know, so I've still got now the issue of finding k. I haven't got to find c anymore. So what other information am I given in the question that's linking n and t?
20 hours.
After 20 hours.
So when t is 20 ends 3000.
Yeah, okay. So there's some more information that was given to me in the question. I was given the information that when t was 20, n was 3000. So substitute that pair into here. I have log of n equals k t plus log of 1500. How would you go about solving that one?
Put the logs on one side.
Put the logs on one side. So bring that log of 1500 across and make it negative. Tell you what, I'll divide by the 20 at the same time, because that will give me k. Log of something minus log of something. Yeah, that's log of the 3000 over the 1500. Over 20 equals k. So 3000 divided by 1500 is 2. So I've got k equals log of 2 divided by 20. Good. I now know what k is. I'm happy again. So I go back to my general solution at the top of the board and I rewrite it yet again. But now I can write it without any k's in. So I get log of n equals kt plus log of 1500. So now what have I got?
Specific.
I have my specific solution. I'll just get some more paper at that point. So, we've dealt with now the very beginning of the question. We sort of dealt with this bit here. We've formulated, and well, we've got the differential equation done. So, we can try and do it a little bit better. If it says solve the differential equation, they will really want it to be in the form of n equals something and not log of n equals something. So now what we're going to do is just sort of play around with that to see if we can write that as n equals rather than log of n at the front. So our aim now is to rewrite this as n equals something. So, any ideas? What might we do from here? At some point that might be good, but try and get some of the log things together first. So, if we first of all bring that log of 1500 across, that's going to leave us over here with log of 2 over 20 times by t. How can I rewrite this?
Van over 1400.
Yep, doing the same log thing we did earlier. Now, I don't want log of n, so here I can do e of both sides effectively. I can do e to the left-hand side, e to the right-hand side. So if I do e to the left-hand side, that log goes, and I get that. That's sort of killed the log. And over here, I have got e to log of 2 over 20 times by t. And if I want to make n the subject, I can do that at this point. I can say, well, n will be 1500 times by all of this. Is there anything else I can do? I'm going to look now at this bit here. Well, the e to the power of that, really, the whole thing there. What I've got here is e to the, I'm going to write it slightly differently, log of 2 times by 20 divided by 20. That's what I've got there. Now, okay, you're using the laws of indices. If you had a power, something here, you're timesing those powers together, what might that have come from?
Bracket, like a bracket of a bracket.
Bracket, I think you mean
Like that.
that, yeah, okay. So I could write this over here as e to the log of 2 to the power of t divided by 20. But what's e to the log of 2? 2. So I've got here 2 t divided by 20. So that red box bit there is this. So actually what I've got here is n equals 1500 times by 2 t 2 to the power of t over 20. And that is the best way of writing down the solution to that equation. So that is playing around here using laws of indices, things like that. So let's go back to the question. We really have finished the first paragraph now. We have solved the differential equation. We've got it written down as n equals, we've removed some logs and e's and things. What is the size of the colony where t equals 80? So what is the size when t equals 80? T equals 80, n equals what? That's what they're asking us now. So what do we do?
Substitute.
Yes, substitute in, yeah. So n will equal 1500 times by 2 to the 80 over 20. That's 2 to the power of 4. So 1500 times by 2 to the power of 4, 2 to the power of 4, 16. So does anybody have a final answer?
Is it
24,000, yeah, okay. So time 80, the size of the colony is 24,000. So we've done that bit of the question. So that was that bit there. Now moving down here, how long did it take to the nearest minute for the size of the colony to increase from 20,000 to, from 2,000 to 3,000? So if we're continuing, I'm just going to write down to start with here so we can see it, the formula that we are using at the moment. And they are talking now about when n goes from 2,000 to 3,000. Now, do we know any t values to go with this?
when it was 3,000, it was 20?
Yeah, we knew from the question that it was the size of 3,000 when it was 20. That was given to us here, okay? When t was 20, it was 3,000. So what do we need to do, first of all, then, to find out how long it took?
And it was t when 2,000, when t is 2,000.
Yeah, so we need to find that value there, what time that was, and then find the difference between the two of them. So what we're going to do now is, we've got n equals 2,000. What we need to do is to find the t value that goes with it. That's our next challenge. Sorry, you couldn't see that, didn't realise. Sorry, if I'm off the board, please let me know. Okay. So, substitute in, I've got 2,000 equals 1,500 times by 2 to the power of t over 20. We all comfortable at solving equations like that? First thing to do?
Take the 1,500 down.
Take the 1,500 to the other side where it's a divide, yeah. What's a nice, easy way of writing 2,000 divided by 1,500? 4 over 3, yeah. So I got 4/3 equals 2 to the t over 20. If you're trying to find out what a power is, what do you do?
Log.
Take log. So logs of both sides. So you want log of 4/3 will be log of t to the 2 to the t over 20. And why have I done that? Because what can I now do on the right hand side?
T over 20 comes down to the front.
T over 20 comes down to the front. That's correct. So if I now move that log of 2, so it's a dividing on the left, I will get t over 20. So if I take the 20 that's dividing by the t over here, and times, I will get my t value. So it's calculator time, plugging it in, seeing what we get for t. What did we get?
8.3.
8.3.
Yeah.
Okay, sorry, pressed the wrong button here. Get that back again. 8.3. 8.3 hours. What's 0.3 of an hour? What's That's 0.3 recurring as a third. What's 0.1 of an hour?
0.6. No, 6 minutes.
Yeah, 0.1 of an hour, 6 minutes. 0.3 of an hour then?
18.
So it's 8 hours, 18 minutes. So we are interested in how long was it from 8 hours, 18 minutes up to 20 hours. So we want to know from that time up to 20 hours, how long is it? Well, from 9 hours to there, it's 11 hours. And how many other minutes are there?
42.
Yeah, so the time, the change in time is 11 hours 42 minutes. And the question said, how long did it take to the nearest minute? So you can either leave it like that, or you can do it in complete minutes. 11 times by 60 plus 42. That will give you an answer of 702 minutes. And thankfully, after 4 pages I've written, that's the end of that question. We've got now a vessel contains liquid which is flowing out from a small hole at point O in the base of the vessel. At time t, the height of the liquid surface above O is z, and the rate at which z is decreasing, that's going to be important, the rate at which z is decreasing is inversely proportional to z to the power of 3 over 2. That's what that says. Write down a differential equation which expresses dz dt in terms of z. And then we've got to do other stuff. So in this question, the letters we are interested in, well, it comes from here really. We're interested in z and we're interested in t. So z, well, what's z? Z is the height, basically, of the liquid. And t is the time. And we are told the height of the liquid is decreasing, inversely proportional. The height is decreasing. What will I write down for the height is decreasing? This is where the differential sort of bit comes in. The height is decreasing. Think back to the last question. It's how the height is changing over time. Go on. dz dt. That is how the height is changing over time. So that's dz dt. So the rate at which it's decreasing is inversely proportional. And what does inversely proportional mean? I'm not just going to write z to the 3 over 2 over here. The inversely bit means? Anyone know? The inversely is 1 over z to the 3 over 2. So the sentence there, the height, the rate at which it's decreasing is inversely proportional to z to the 3 over 2 gives you that. What do we change the proportional sign into? From last time, the proportional sign gets changed into equals k times by. Okay. And there's one other thing here. It's decreasing. If it's decreasing, I will put a minus sign in there because it's decreasing. So there is my differential equation. So if I've now got my differential equation, what do I always do to differential equations?
Separate the variables.
Separate the variables. I will keep the z's on the left because there's a dz on the top there. I will bring this z to the 3 over 2, which is on the bottom of that side, up to the top of this side. So that will be there as a z to the power of 3 over 2. I will keep the minus k where it is. Only other thing I need to include is the dt, which is on the bottom one side, go on the top the other side. And once I've separated my variables, I integrate. Okay? So, what do you get when you integrate z to the power of 3 over 2 with respect to z? You add 1 to the power and you divide by the new power.
2z over 5.
Okay, you're one step ahead of me. Yeah, you'll put the 5 over 2 and divide by the new power. Remember, dividing by 5 over 2 is the same as timesing by 2 over 5, which gives us what Jack just said. What do you get if you integrate minus k with respect to t? Minus kt. I have finished integrating. I write down plus c. Right, what information have I got in the question? That will help me. I actually now need to move down, so I've got a differential equation which expresses, I've got this bit here, expresses dz dt. I had that at this stage. I've gone to solve it. What information have I got now in the question that I can use?
Z equals 25 when t equals 0.
Use z equals 25 when t equals 0. So if I put that in, I've got 2 lots of 25 to the power of 5 over 2 over 5 equals, when t is 0, that k bit will disappear. So that's actually what my c is. Now, if you bung that into a calculator, 25 to the power of the half is 5. So you're doing 5 to the power of 5. Dividing by 4 by 5, that's actually 5 to the power of 4 is 625 times by 2, 1250, which is what your calculator should tell you. So I now know c, so I can rewrite the equation that's at the top of the board. And what other information can I use from the question? Somebody else find something in the question I can use?
Z equals 16 when t equals 30.
Yep, okay. So put that information in. Save a bit of time, shall I just tell you what k is? Because we're running towards the bell. If you did rearrange that, you would get k is 28 and 1/75. Okay? Which means we can rewrite that equation at the top of the board, yet again.
Do you keep the minus?
Yep. That's a good question. We will keep the minus. That's showing it as decreasing. And the question finally said, find the value of t when z equals 0. So we've now got z equals 0. Find the value of t. What will the value of the left-hand side be when z equals 0? What will this be over here? That will be 0, yeah, because it's got a 0 in there. You could solve that equation. To save time, I will tell you the answer is 44.62. So there we are, a question done in less than half the pages and half the time of the last one.